Solve this equation. We have log base 4 of 2x plus 1 minus log base 4 of x minus 2 equals 1. What can we do with this? Well, this can be combined. We have the same base of our log, and we're saying log of the same base, and we're subtracting the two logs. That's going to be combined to one log with it being divided, each piece being divided. So 2x plus 1 divided by x minus 2. And that equals 1. So this is a log equation. We want to solve this log equation. We want to transform it to an exponential equation. The base of our log is 4. A log is an exponent, 4 to the 1, equals 2x plus 1 over x minus 2. At this point, it's a regular equation, so you can multiply both sides by x minus 2. So we get 4x minus 8 equals 2x plus 1. Move the x's to one side, the numbers to the other, so x is 9/2. Here's another problem. We did one like this in the last set of notes. This is going to add another layer to it, because in the last one we said what we want to do is get it in terms of 5 and 4, but there's another number that's hidden in there that we also can use. And what is that number? That is the base, because log base 9 of 9 equals 1. So let's take a look here. When we have 100, we're going to factor this down. This is 25 times 4. 4 is what I want, and 25 is 5 squared. So we could write this as log base 9 of 5 squared times 4. Now we can say log base 9 of 5 squared plus log base 9 of 4. Again, to emphasize this, I don't want you substituting in terms of these variables until you get it so it just says something times log base 9 of 5 and or 4. So we bring that 2 out in front. 2 times log base 9 of 5 plus log base 9 of 4. Now we could say that's 2x plus y. I would strongly recommend you trying to do all of these and then check with a video. It will be much better for you, because you're going to have to do it on your own, and it may or may not be easy. On this one, we'll have log base 9 of 9 times 4. Now I want to keep those because I have log base 9 of 4 and log base 9 of 9. I know what that is as well, because that's just 1. Now note, sometimes doing these problems you could have multiple different answers, or they appear different but they're really equal. And that's just one of the things that happens when you're dealing with logs. Over here, when I see a mixed fraction, I want to change it to an improper fraction. So I'm going to say 6 times 4 plus 1, and we'll get log base 9 of 25 over 4. So this is log base 9 of 5 squared minus log base 9 of 4. Again, move that 2 out in front. Log base 9 of 5 minus log base 9 of 4. So I get 2x minus y. Now let's deal with that last one. Log base 9 of 3.2. I see this decimal there. I don't want a decimal. I want to treat it and convert it to an improper fraction, similar to what I just had there. So this would be log base 9 of 3 1/5, because 0.2 is the same as 2 over 10 or 1 over 5. So 3 times 5 plus 1 would be 16 over 5. And we have log base 9 of that. So that'd be log base 9 of 4 squared minus log base 9 of 5. Bring that 2 out in front always. And now we can do our substitution. This time we have 2y minus x. And that's the basic. Sometimes what you get here may or may not be so easy to see. You just you have to keep on trying to get whatever these three numbers are, the 5, the 4, or 9. All right, how is the graph of log base b of x squared related to the graph of log base b of x? Well, it depends on what's going on here. So let's take a look at what log base b of x looks like. Remember, that's kind of our standard graph here. This is 1. And then at b, log base b of b would be 1. And if I graph this thing, right, the way this is currently written, that this has a domain of x cannot equal 0. So we can include negative numbers because when you square it, you get a positive number. There is some things that are going on here that are not so easy. But when I have that 2 there, I can bring the 2 out in front. But one of the things about this is technically I can still deal with this as an absolute value. Now what I want to do for this particular problem is I want to deal with this only for x greater than 0. And then we don't need to worry about that absolute value. So what does this do to the graph? Well, if f of x is log base b of x, then this is looking at 2 times f of x. Well, what does that do to the graph? That's multiplying the y values by 2. So we're going to take our graph here and we're going to double all of y values. So instead of having here at 1, it's going to go up to 2. Instead of being at negative 1, it's going to be at negative 2. So it's stretching this graph out. And let me redraw that since I missed my 1 value. It's okay to redo it. So the bottom graph, always label your graph. This is log base b of x. And this top graph is log base b of 2 times log base b of x. If I were to include all numbers, not just the positives, then the log base b of x graph would be reflected about the y-axis because it would be an even function. It would be symmetrical about the y-axis. All right, express y in terms of x. Or in other words, solve for y there. This is an exponential equation, or this is a log equation, and we want to convert it to an exponential equation. What's the base of the log? 10. It's our common log. So we will say 10 to the 2x plus 3 equals, because remember a log is an exponent, equals y. And that could be simplified to 10 squared times 10 cubed, and I'm going to move that 10 cubed in front, so it's 1,000 times 10 squared, which is 100 to the x. So we've solved that. There's our equation. We're done with that part. There's part A. Part B. What kind of equation relates log of y and x? What this is basically saying is, let's think of log of y as one variable. Let's call it z for just a second. Z equals log of y. So if I have z equals 2x plus 3, what kind of equation is that? Well, this is a lot like y equals mx plus b. This is a linear equation. What kind of equation relates y and x? Well, this is of our form a times b to the x. So when you have a times b to the x, that is an exponential equation. All right, next one. We're going to need our calculator here. Now, before you do these kind of problems, what I want you to do is I want you to tell me between what two numbers is our answer. So we could say that x has to be bounded by what two numbers? Well, what is a power of x that is two consecutive numbers as well? What's a power of x that is smaller than 100 and the next one that's bigger than 100? So you could just start rattling off. You have 2, 4, 8, 16, 32, 64, 128. So it's 64, and that is 2 to the 6th power, and 128, 2 to the 7th. So in other words, that x is going to be in between 6 and 7. So when we start this, what we're just going to do is, let's go over here to our table, and let's see, and let's type in 2 to the x power. Then let's go to Actually, so I'm sorry, I went to the y equals. Now let's go to our table. And I can delete anything I have there. And let's start typing in some numbers. Let me just guess in the middle there, 6.5. That's not it. 6.8. That's too high. 6.7. So it looks like we're in between 6.7 or 6.6 and 6.7. Which one are we closer to? It looks pretty close to even there, maybe slightly closer to 6.7. Let's try 6.65. 6.64. Now we're pretty close there. We're going to need to go another spot just to make sure. It looks like we're going to be closer to the 6.64 because that's going to be closer to 100 than the 100.43. Just to make sure, let's go 6.64 and let's try 4. Oh, that is so close. Let me go back up here and delete. So on our calculator, what I want you to, or on your paper, what I want you to do is write down some of these values. I'm going to delete the ones that were too big. And I'll come back here and say 6.645. Well, we're closer to the 6.644, so that would be, the answer is approximately 6.64. On your paper, I want you to write down our 6.6, 6.7, 6.64, 6.65, and then 6.644. And then just copy those values down. This is basically saying, okay, we're going to guess it. We're using our calculator to figure it out. And now what we'll do is 100.01. So our answer is x is approximately equal to 6.64. Remember, the 100th place is 2 decimal places. Now, there's another method. And what is that other method? We are trying to solve an equation, an exponential equation. It has a variable in the exponent. Well, what else do we know that's an exponent that we've been dealing with? Logs. So what we can do here is take the log of both sides. The log of both sides. So now we can let's just focus on this last part. Which rule are we going to use when we have log base 10 of 2 to the x? We have an exponent here. That exponent's going to come down. So we have x log of 2 equals the log of 10 squared. Now, why am I doing that? Because now they have the same base, and that's just going to give us 2 in this particular problem. So we have x log 2 equals 2, so x equals 2 divided by the log of 2. And you can take out your calculator and type that in, 2 divided by log 2. So this 2 over log 2 is an exact answer, and our approximate answer would be 6.64, and that says, so I'll put a wavy equal sign, 38, etc. So when we had 6.44, that was a pretty good guess, or 6.64. And that is it.